Anything in the universe that has mass is made of matter. Matter can be classified into two major categories: substances and mixtures. Substances can be further classified into two other categories: elements, which are anything that you see on the periodic table, including hydrogen, carbon, nitrogen, or oxygen, and compounds, which are made up of two or more elements. For example, water, H2O, which combines hydrogen, H, and oxygen, O. Mixtures, the other class of matter, is composed of two or more elements or compounds. Mixtures can be classified into homogeneous mixtures, which are uniform in composition. For example, salt water, which is a mixture of salt and water and has a clear, uniform appearance. And the other class of mixtures is heterogeneous mixtures, which have a non-uniform appearance or composition. For example, sand and water. If we put sand in water, the sand will come to the bottom and the water will remain on top. So we have a mixture which has sand on the bottom and water on the top. So that's a non-uniform composition, which makes it a heterogeneous mixture. An example question we might see is, which of the following are substances and which are mixtures? And we have four choices: A, helium, B, juice, C, red wine, and D, salt. So let's start with A, helium. If we look at the periodic table, we see that helium is listed as an element. So since we know that elements are substances, we're going to call that a substance. Juice is composed of multiple things. For example, water, sugar, and orange flavoring. So we're going to call that a mixture. Red wine is also composed of multiple things. For example, water and alcohol. So that is also a mixture. Salt is a tricky one. Salt is actually a compound. The table salt that you might find is actually NaCl or NaI or something along those lines. So that is a compound or a substance. Another question you might find is, which of the following mixtures are homogeneous and which are heterogeneous? And we're given another four choices: A, gasoline, B, raisin pudding, C, salad dressing, and D, salt water. So let's start with A, gasoline. Gasoline, if you've ever seen it, is a uniform liquid which combines different hydrocarbons, but when you look at it, it has a uniform appearance, so that is a homogeneous mixture. B, raisin pudding. Raisin pudding has raisins spread out randomly throughout the pudding, so that is a mixture of pudding and raisins, which is non-uniform in appearance, so that is a heterogeneous mixture. C, salad dressing. If we look at a bottle of salad dressing, we see that there are different parts of this salad dressing and different parts of the ingredients that are spread out randomly throughout the bottle, and it doesn't make a uniform appearance, so that is also a heterogeneous mixture. D, salt water, we use that as an example of a homogeneous mixture, because when you dissolve salt in water, it disappears and makes a uniform mixture, which is homogeneous. The next topic we're going to talk about is physical versus chemical properties and changes. Physical changes or physical properties are observable changes or observable facts. For example, bending, freezing, melting, stretching, or the fact that a certain object or compound or element is a color. These are all factual or observable changes. So these are all in the physical category. Chemical changes or chemical properties are the ability of a compound or element to react. So anything that describes reacting, burning, rusting is all under the chemical category. An example question that we might see about this topic includes identifying the following as physical or chemical properties. So A, solid iron melts at 1535 degrees Celsius. We've listed melting as a physical observable change, so that is under the physical properties category. B, solid sulfur is yellow. We've also listed factual things or colors, the fact that an object or element is a color, as a physical property, so that's a physical property. C, natural gas burns. We've listed burning as a chemical change or a chemical property, so we're going to call that a chemical property. And D, diamond is extremely hard. We haven't listed hardness as a physical or chemical property, but if we think about it, the fact that diamond is extremely hard has nothing to do with its ability to react. It's an observable fact about diamond, so that falls under the physical category. Moving on to density. An object's density is its mass divided by its volume, or density D is equal to mass over volume. What is the density of a salt solution if 50.0 milliliters has a mass of 57.0 grams? We've said that density is mass divided by volume, so we're going to take our mass of 57.0 grams and divide it by 50.0 milliliters. Doing some quick math, we get that density is equal to 1.14 grams per milliliter. We use units of grams per milliliter for our density because we've divided grams by milliliters. What is the mass in kilograms of a 25-liter salt solution that has a density of 1.3 grams per milliliter? We've said that density is equal to mass over volume, so we set our density, which is 1.3 grams per milliliter, equal to the mass of the salt solution divided by the volume. Now if we notice, we're given a volume of 25 liters, but our density is 1.3 grams per milliliter. Liters and milliliters do not match up. So in order to solve this problem correctly, we're going to have to convert either liters to milliliters or grams per milliliter to grams per liter. Since it's easier to convert liters to milliliters rather than convert grams per milliliter to grams per liter, I'm going to convert 25 liters to 25,000 milliliters by multiplying by 1,000. Now we can plug in our volume. Density is equal to 1.3 grams per milliliter, which is equal to the mass of the salt solution divided by 25,000 milliliters, which we just converted as a volume. Multiplying 1.3 grams per milliliter by 25,000 milliliters, we get the mass of the salt solution is 32,500 grams. And since the problem asks for the mass in kilograms, we divide our 32,500 grams by 1,000 to get 32.5 kilograms as the final answer.